It's Don here from the board. Thanks for coming along and checking out this video. So, a couple of weeks back you would have seen the latest part in regards to keyboards and microphones where I talked about the comparisons between various microphones that I have in my collection and how their pickup represents my daily driver at home differently. And after doing all of those videos with the different microphones and then having a look at the results and checking out different references about how microphones work and how our ears work, I kind of wanted to extend that a bit and consider more down to a switch level if possible. And it got me thinking about, is it possible to actually see, using a frequency response curve, different characteristics of switches with our microphones? And part of that internal thought pattern and discussion that I had about it was more around standardization, right? We have all these different streamers, we have different people who are content creators, they review switches and they do sound tests. Now, very recently, there's been a video which talks about how sound tests are a complete lie. And there's some really great points in that because there are so many variables that impact how a keyboard sounds. To get around some of that, though, if you strip a lot of that away and go down to, say, a switch level, a lot of those factors disappear. However, you still have the issue of, for example, different audio equipment. So I thought about it, and what I came down to as an idea, and that's what we're going to be having a look at and exploring in this video, is if we were to pick an audio setup that is readily available to all streamers or all of those people who want to do sound tests at a switch level, then there's no reason why we couldn't produce comparative data. And when you think about it from that point of view, you have to pick something that is affordable, has decent quality, has as little as possible processing outside of the microphone to deal with. And because of that, I chose it to be a USB based microphone because that eliminates issues of the cables to a mixer, the quality of the mixer and the internals of the mixer, such as its preamp and settings on the mixer, and then the chain to the actual PC and the processing of that from a potentially analog to digital signal. Of course, there are mixers who already do that automatic conversion to a digital signal, but once again, that becomes part of the chain that could be different between different people and streamers. Whereas if you pick a purely USB output device, all of that processing happens on that device and should be the same. So that digital signal all the way carried through should be the same, and it just becomes a recording in your recording software. Now, I normally use Audacity because it's open source freeware and therefore it's open to everybody. So, the settings there I have are pretty much default. I don't really do anything, but I can talk through about how I process it, and if it's processed exactly the same, then of course, you would effectively get a similar result for comparative purposes. So with that in mind, I decided to use my Rode NT USB because it's readily available. It's a sort of midpoint microphone, not microscope, and it's USB. It has good sound characteristics, and a number of streamers and reviewers already use it. For example, I believe Tay Keyboard uses the NT USB because he got it before they had the USB Mini. Now, I don't have the USB Mini, so I can't really talk very well about that. Maybe one day if one comes across my collection, that'd be cool to check out as well. So, then you got to think about, how do you actually measure the switch sound? You can have different switches, you can have different switch plates, and all that kind of stuff, and it could be quite challenging. So I went ahead and designed an enclosure for my NT USB that would make it consistent. and it being 3D printed means that everybody could produce one if they had access to 3D printing, or get someone to print them one, send it to them, or use a 3D printing service. And that, once again, eliminates a lot of those variables. If you use, the same or similar print materials and settings and so on and so forth. So let's have a look at what my wacky idea has actually resulted in. So we'll go down to the desktop, and this is what I've got here. I've moved it to the side because the autofocus is having a field day trying to focus my table and the microphone, because the microphone's much higher, but everything else is on the bottom focal plane. But what I have here is an NT USB. Now I'm just going to take it off the actual stand so we can have a look at it a little bit better. Okay, so here's the NT USB, and it's got all sorts of stuff on it because I wanted to isolate external sound. So you'll notice there's a whole bunch of cork that's apparently taped on it. Now that's not 100% true. What it is, though, it is sitting on it, and what I've done with it is I've basically got it as a slip-on. So I have this shroud bit here that covers the front, and we'll talk about that in a moment. And then this also lifts up so that you can pull this whole thing off. So it's printed in 3 parts because I wanted it to print well on my machine. My machine's not a very good printer. It's pretty old. It's got some issues, and you can see there's warp and stuff. But as a prototype goes, I'm relatively happy with it. The actual profile for it, you'll see I've modeled it to fit around the actual microphone as best as possible. It is snug. Okay, so if I am to take that off, you'll see there's the top part, and it's got a solid roof. Then there is this mid section, which has a very familiar 14mm by 14mm section, and this is it's on there, but it's not super duper firm. And then this bottom part is much firmer to move. And that's in effect of printing and shrinkage and tolerances, but also it helps because the other part sitting on it, that middle ring is not going to slide down off the bottom end of this. So the concept here is really simple. Once you get these 3 parts on, you want to make sure that top is all the way in, right? And the cork is just there to try and help absorb a bit of environmental noise, a bit of extra sound that might be around. So we're just going to pop that on. I'm going to put my bit of Velcro, spare Velcro, cable Velcro that I have. You can use, I don't know, another elastic band or whatever you like. And that will just help keep that there. Now, I'm using a paperclip as a plunger. The plunger goes through the hole in the top, like that, and it reaches all the way in, and it essentially allows you to actuate the switch. It's thin, low friction, shouldn't produce too much noise. It's not lubricated or anything like that, doesn't really need it, but if you use the same setup, then it's going to be consistent. Whatever sound that it produces is going to be consistent, and therefore, once again, consistency enables comparisons, right? This front bit, once again, it's more cork just to try and absorb some of the extra frequencies and sound outside. It's just messy because I had to pad it up, make it thick, so when I slapped it on the front, my elastic band would actually hold it in place properly. So it's a bit of a kludgy kind of thing, and unfortunately the top is exposed because, well, I've still got to be able to get that moving, right? So when you have it all set up and you're ready to go, you can basically take that out. Here's just a cream switch. I'm going to orientate it so that it's got the LED part facing forwards, and I'm just going to fit it into the footprint, into the switch hole, just like that. It clips in, okay, sits in there quite neatly, and this plunger goes into the top, and you'll see it actually sits on top of the stem, and I can actually actuate that and you can hear it, right? It makes a sound. So then you cover that up the front, and then you slap this on it, and you have a very poor person's edition of a sound chamber, kind of like what Cherry has in their sound lab that you may have seen in a video when, I can't remember who it was, maybe it was Linus, who went and had a look at their factory, and they've got this big, heavy insulated box, and it allows them to do sound tests. So this will stand vertically. Now I'm not going to plug it in, because if I plug it in and the microphone recognizes it, then it'll try and use the USB rather than the XLR microphone that I've got at the moment. And then of course you'll turn on your recording, you'll leave it record for a certain amount of time to get background noise, because you're still going to have environmental background noise and self noise from the microphone. And then when you're ready, you press the plunger. Now you try and do it consistently, and I believe you should press it for a minimum of 25 times. I'm going for full bottom out as well, because it's the only way that you're going to have consistency in travel and force. Of course, you'll probably get some variation in force as you press it 25 times, but hopefully that will even out, because when you go between different switches, you'll have the same issue. And you can get practiced, I suppose, in how much you press. Now, for everybody who talks about using motors and gears and things moving up and down like they do at the Cherry testing, yes, you can. I just don't have that here. I don't have that set up, and that's a lot more work, whereas this, as a proof of concept at least, is just a kick point to run with this. I'm sure other people who watch this, for example, like Mr. Keeves, who did such a fantastic job with my switch breaker innerer, could absolutely smash out something that would work with this. In any case, once you do that, you're going to end up with a frequency, you're going to end up with an audio file, right? So that's the physical setup. Now, I have set the microphone so that it is, lowest on the headphone and all the way to the microphone sound, because you don't need to hear the PC audio that could come through on this jack. So just to make it nice and simple and consistent. So that's the physical setup, and that's how it works. I do it without a keycap, because obviously a keycap is going to change sound characteristics within that little chamber, as well as absorb sound and change how the sound may be reflecting from the actual switch. Okay. Now, I did this with a Cherry MX Black, and I'm going to show you what that looks like. If there we go. Okay, so this is in Audacity, and this is my background noise section at the start. So I've got about 10 seconds of background noise, and then here is the actual 25 clicks, right? So you can see there's some variance. There is some variance between them. Some of these lines are thicker, therefore they're louder, and some of these lines are thinner, but the 25, the n equals 25, at least gives a better bell curve, I suppose, more than anything. Now, of course, if you went and used machinery and a motor or whatever to actually actuate it and provide that consistency, fantastic. But for proof of concept, I want to repeat, prototyping, proof of concept, that's the reason why I did it. Okay. Now, it is hard bottom out. It is hard bottom out. So what I'm going to do now is I'm going to play you what that sounds like. Hopefully this works, because I don't really play desktop audio very often into my videos. I do apologize if it's loud or etc., but prepare your ears possibly. Okay, so that's what it sounds like. It's actually quite isolated. Now, you do hear a lot of that sort of grinding noise, which I don't really know 100% if it's the plunger or if it's the actual switch in the stem, because it's an unlubed switch. It's just a straight up MX Black, okay? So to process it, because we've got this lovely bit of self noise at the front, which I didn't play, so if we play the self noise and the background noise, you can't really hear very much, but it's still there. It's still there. So, you can take that noise and you can do a noise reduction on it. You can grab the whole sound sample there. You can noise reduce and reduce that quite significantly. And then once you've got that, you're going to go from about there to the end. You want to kind of capture it before that is the bounce. That little bit down the end is the bounce of me taking my finger off the actual plunger. And you can do a plot spectrum. And what you end up with is a graph, right? And so it tells us that around that almost 2 to 3,000 hertz range, which we talked about in the other video on the microphones, which is our sensitivity is around that 3,000 hertz range, it's actually quite loud. But then in this lower bassy area, it's not as loud. But then, it has a particular shape to it. That doesn't mean anything by itself, right? It means nothing. So until I go and do other switches and then put these curves together, then we can have a look at, does it actually make a difference? Using the same methodology, can I see between the different switch types what switch is potentially quieter, scratchier, deeper, tinnier, like all of these words and characteristics that people talk about on switch sounds in switch isolation, just the switch alone. So, yeah, that's my working prototype, and that's one switch. So because I've done an MX Black, and I've actually got a number of black linear switches in my collection, that's the reason why I chose that, right? I specifically wanted to compare black switches, so there'll be like a Gator-on black, and I've got a vintage black, and I think I've got a box black, right? And that will allow me to put some of those linears in and measure them through this and see what that looks like and how that actually comes out on the graph. And then we can basically say it works. We can see some differences and it's actually visible, it's notable, and those characteristics reflect in what we actually hear. Or we can say that this prototype, this concept is complete rubbish and it doesn't work. So this is just pushing the boundaries of design, 3D prototyping, sound, and of course, keyboards. So, yeah, there you have it. Anyhow, please, would love to get your feedback down below in regards to what you think about this. Next week, I'll post up the following results for this because, having this set up on my desk, it's quite big, it's quite cumbersome, and then doing the recordings is actually relatively easy. And in terms of popping out the switch, you just push it out from below, pop in the next one, and away you go. So I should be able to get those done pretty easily, just in a row, put some time aside to that, and then churn out these frequency analyses, stack them together in a graph, and then we can have a look at it. So comments below, let me know if you think it'll work, if you don't think it'll work, if it won't provide any values, any flaws in my thinking and methodology here. I'm not an audio engineer, I'm not a specialist in this field. I just throw these ideas out there and try and make them happen. In any case, thank you very much for coming along and checking out this video. I hope you enjoyed this particular thought process and what it might entail. And hit that like button, subscribe button, dislike button, even if you want to. Let me know. All right. Of course, as usual, until next time, happy clacking.